We're going to be talking about area between curves today. It's the last topic you learn in calculus, at least for this course. And what we're going to do is it follows a three-step process. I'm going to say step 0 because it's like the first thing you should do if they don't give it to you. Sometimes they do give it to you, but if they don't, you need to draw a graph of what's going on. Draw a graph. If you're not good at drawing graphs, I don't know what to tell you. You need to know just a couple of them. You need to know what x squared looks like. You need to know what x cubed looks like. You need to know what the square root looks like. Let me just write these down real quick. You need to know what like y equals x. You need to know what y equals x squared looks like. You need to know what y equals x cubed looks like. You need to know y equals the square root of x. You need to know y equals e to the x. You need to know y equals natural log of x. And by the way, I say you need to know them. You don't need to know them, but they're going to make your life a lot easier when you actually go and do these problems. Now, there's probably like a bunch more that could potentially show up on the quiz or test, but for the most part, this is all you need to know. You can get away with knowing these 6. Any questions? So then step 1, the real step 1, after you draw the graph, and by the way, this is an optional step. I'll even put this in parentheses. It's optional. You don't have to do it. Step 1, you don't have a choice. You need to do this. You need to find the intersection points. Find the intersection points. What does that mean? We're going to talk about that, but I'm going to put this in parentheses. Set the functions equal to each other. That's how we find intersection points. We're going to set the functions equal to each other. Yes, we're dealing with at least 2 functions whenever it comes to area between curves. And then finally, step 2 is the actual calculus or math part. You're going to solve the following integral. The integral from x1 to x2, which is really just the leftmost point to the rightmost point of the top function minus the bottom function dx. And we're about to look at 6 examples today, or maybe, yeah, I'll say 6. I hope we can finish within an hour. I think we will. But any questions so far? Okay, so we're going to follow this 3-step process. 1, draw a graph, which is technically optional, but we're going to do it for most of the problems today. The real step 1, find the intersection points by setting the functions equal to each other. And step 2, find the integral from x1 to x2 of the top minus the bottom dx. This is the most important step, step number 2, which is why we're going to spend the most time on it. Okay. So now, here's the first problem. Everyone ready? I want to find the area between y equals x squared and y equals x to the 4th. I know I didn't put x to the 4th on there, but you can imagine kind of what it looks like, even if you don't know. So first thing I'm going to do is I'm going to draw a picture. I'll draw y equals x squared in blue, and I'll draw y equals x to the 4th here in red. Now I do need to be careful here how I draw it. It's going to look like this. Pretty much, you can see where it intersects here. And by the way, again, if you didn't know this, it doesn't matter. You can still solve the problem. It's not a big deal. Okay, but I'm actually, if you want to zoom in or whatever, I mean, I can't really zoom in, but I'm going to draw the area here in green. Hopefully you can see that. That's really small. But you see the area. You see the area. And the reason why I like to draw the picture is because it helps me determine which function is the top function and which one's the bottom function. The other reason, this is a particularly devious example because I'm actually going to need 2 integrals here. So step 0 is done. I drew a picture. Step 1, I want to find these intersection points. In this problem, there are 3 intersection points. I'm going to draw them all. There's one here, there's one here, and there's one here. I forgot to label these. The blue is y equals x squared. The red is y equals x to the 4th. Again, if you didn't know that, you don't need to. You can still solve the problem without knowing that. Now, real step 1 is find the intersection points. Again, how do I find intersection points? Set the functions equal to each other. X squared equals x to the 4th. Okay? Now we need to solve this. For those of you who out there who want to cancel out x squared and then we have x squared on the right, never cancel out x's. If you cancel out x's, you're losing solutions. In this case, you'd be losing the x equals 0 solution. So what do we do instead? I'm going to say this. I'm going to subtract x squared from both sides. So 0 equals x to the 4th minus x squared. Now, this is not an easy function to solve unless you know what to do. And what you do here is you need to factor out the common term. The common term is x squared. If I factor out x squared, what am I left with? I'm left with x squared minus 1. Okay? Now, hopefully, you see what's going on here. I could even factor x squared minus 1. So I have 0 equals x squared times, if I factor x squared minus 1, that becomes x plus 1 and x minus 1. Now I see my three solutions. I have x squared equals 0, x plus 1 equals 0, and x minus 1 equals 0. Which means I get the following three solutions. X equals 0, negative 1, and positive 1. These are the x points of my intersection points. So look at this. Negative 1 right here, 0 right there, and positive 1 right there. Those are my x points. Any questions so far? Okay, great. So now I'm going to set up the integral. The integral, again, there's going to be two integrals here. Why am I setting up two integrals? Well, because there's two green shaded regions. There's two areas. And if I have two areas, which again, this is not normal. This is a particularly hard example that we started off with. And, well, if I knew it was going to be this hard, I wouldn't have started with this one, so I apologize. But it's going to be two integrals. It's going to be integral from negative 1 to 0. Because remember, it's integral from x1 to x2 of top minus bottom, right? So x1 and x2, those are my x points, negative 1 and 0 for the first one. The top function, just look at the left side. The top function is x squared. So it's x squared minus x to the 4th dx. There's my first integral. Great. Any questions so far? Okay. Plus, my second integral is going to be the integral from 0 to 1. Those are my second set of x points. And that's going to be the top function. Again, it's x squared minus x to the 4th. That's supposed to be a 4. And then I ran out of room, but put dx there as well. Okay, any questions so far now? Okay, great. So now
actually, I have a question.
Wait.
Sorry.
Yes, let's hear it.
How do you know which function goes first?
Okay,
Like,
so does it make sense when I'm saying top minus bottom? If not, please
are
tell
you
me.
saying like which one's bigger?
No, I'm saying, like, I'm looking at this. I can even draw it bigger, like down here. I'm saying, if I were to draw this like really, really, really big, I should have color coded it. Hold on. So the blue is this one, and the red is this one. I'm saying which function's on top.
Yeah, I don't really get what you mean.
Okay, fair enough. So I'm going to draw vertical lines here. Maybe this is a way to see it. It looks like a smiley face with teeth. But if what are my black vertical lines? What's the top touching? What color? What color is the top touching? The black.
The blue?
Yes. What's the bottom touching?
The red?
That's what I mean. Does that make sense?
Yeah.
Now, this is a visual representation. It then begs the question, well, how do we solve this problem if we couldn't draw the graph in the first place? And I was going to talk about that right now, actually. But first, someone else had a question. What was the other person's question?
When you're doing this, are you like reading it from like left to right, like you're starting at negative 1?
I like to. Yeah, I like to, but technically the order doesn't matter.
Okay. And could you just find one side and multiply it by 2 or no?
In this case, since it's symmetrical, yes. But
that's rare, right?
So pretty much, it really depends. It's not rare in the sense that it makes sense because they don't want to screw you over that hard on the quiz. And as I say that, I realize, yeah, they actually do like screwing you over that hard. So if you see it's symmetrical, yes, you can multiply by 2. If you don't know, like maybe it's symmetrical, maybe it's not, don't risk it. You know what I mean?
Yep. All right. Thank you.
Yep. We're going to do this the long way, though. And the other thing I want to mention real quick is what if you couldn't draw this? How do you know which function's on top and which one's on the bottom? Because that's a good question. So we found the intersection points, right? It's 0, negative 1, and positive 1. I'm going to make a number line again real quick. This is not the number line for first derivative test, but it's similar. But what I need to do is I need to figure out which function in not each of these regions, but only the regions between -1, 0, and 1, right? Like those are the only points I care about. I want to know which function is bigger, the blue or the red, x squared or x to the fourth. And to do that, I need to plug in a point between -1 and 0 and another point between 0 and 1 into both functions. So that's kind of confusing. Let's do it together. So we have the two functions y equals x squared and y equals x to the fourth. First, I'm going to plug in a point like -1/2 in between -1 and 0. If I plug in -1/2 into both functions, I get y equals -1/2 squared, which is what? +1/4, right? And then the other one's y equals -1/2 raised to the fourth. If you had a calculator, you'd get 1/16 for that. Which is the bigger number, 1/4 or 1/16? It's 1/4, right? It's the bigger fraction. Which means between -1 and 0, y equals x squared is on top. And by process of elimination, y equals x to the fourth is on the bottom because it's smaller. Does that make sense?
So are you doing like the larger function minus the smaller?
I don't like that word, but if that's how it makes sense to you, then yes.
So it's like whatever number you get that's bigger.
Yes.
Is the function that goes first.
Yes.
Okay.
And then if we did 0 to 1, I mean, you can see it in the picture, and you also know that since it's squared, you're going to get the same results. Y equals x squared, again, that's on top. So that's another way of proving that it should be x squared minus x to the fourth. Okay. So now that we have this, I'm now ready to solve my integral. Since we did a lot of solving integrals before in the last quiz, I'm going to go through this super quick. So it's going to be x squared minus x to the fourth. I'm just going to tell you, x cubed over 3 minus x to the fifth over 5. This is evaluated from 0 up top, -1 on the bottom, plus my integral, plus the quantity x cubed over 3 minus x to the fifth over 5. But this is evaluated from 1 up top and 0 on the bottom. And since personally, I mean, how fast is this to do in my head? Let me just do it real quick. So if I plug in 0, the first term is just 0 minus 0 minus, and again, you have a calculator for this, but -1 cubed is -1/3 minus -1 to the fifth over 5 is -1/5. That would then become positive, plus I plug in 1 here, it's 1/3 minus 1 to the fifth, and then minus 0. So this comes back to the symmetrical thing we were talking about earlier. You're going to get 1/3 minus 1/5 plus 1/3 minus 1/5, which is essentially 2 times the quantity 1/3 minus 1/5. We'll get, if I break this into 15ths to get a common denominator, it would be 5 minus 3 plus 5 minus 3 over 15. Just got a common denominator. And so it's 5 minus 3 is 2, plus 5 minus 3 is 2. 4/15 is our final answer. Again, you have a calculator. I'm not worried about this part for you. But any questions on the process, the drawing the picture, setting up the integral, me plugging in the formula, any questions at all?
Can you scroll up for a second?
Yep.
Just one?
Like this far? Or higher?
Yeah, that's good.
Okay. So if you do have questions and you're afraid to ask, we have, 5 more problems to do tonight? And I was about to say this is the easy one, but no, this was actually the hard one. It only gets better from here. Good news. Actually, I'm looking at my paper one more time. This is the second hardest one. Okay, I'm gonna move on. Okay. Here's number 2. I have the two functions y equals 1/2 x and y equals the square root of x. And once again, I want to find the area between these two. So again, it's really helpful if you can draw these functions. Luckily, I know what the square root of x looks like. It looks something like that. Let me color code it again. So square root of x looks something like that. Y equals square root of x. And 1/2 x, well, that's just a linear line with a slope of 1/2. So it's going to look something like this. Y equals 1/2 x. Now I can see my intersection points here and here. I don't know exactly what they are yet, but I know I'm looking at this area right here. And just looking at this graph, I know which function's on top. Person who asked the question earlier, do you see which function's on top? I don't mean to call you out. I just want to know if this makes sense.
Is the red one on top?
Yes.
Okay.
And even if you didn't know, again, if you have no idea what's going on at the top and the bottom, you can find out by plugging in the number line, seeing which function is higher in this range. But before we do that, we do need to find out where the functions equal each other. We need to find these intersection points. How do I do that? Again, we're going to set them equal to each other. 1/2 x equals the square root of x. To solve this one, the first step is actually square both sides. It's not fun, but we have to do it. Square both sides. On the left, you get 1/4 x squared. On the right, square root of x squared, you actually just get x. Very cool. Now these x's cancel, right? No, do not cancel out the x's. What happens if you cancel out an x? You lose a solution. Don't cancel out x's. You need to subtract x from both sides. 1/4 x squared minus x equals 0. And again, what did we do last time? We factored out an x. We'll get x times 1/4 x minus 1 equals 0. Now we just need to set both of these individually equal to 0. I'll write up here. So x equals 0 is one solution. 1/4 x minus 1 equals 0 is the other solution. So we need to solve this. 1/4 x equals positive 1. Multiply both sides by 4. You get x equals 4. So we have our two intersection points, x equals 0 and x equals 4. Any questions how I got that? Notice these problems are very fun. Very fun. X equals 0 and x equals 4. In case you're wondering, that book of 1001 calculus questions that I got from Barnes & Noble, that costed $22. So not that expensive. Definitely cheaper than your textbooks, but more expensive than anything else you can find online. I actually like the paper stuff, so I got it. I make enough money that I can splurge every once in a while. You know, I was either going to do that or ask for it for Christmas, but I decided to go out and buy it anyway. I have some other textbooks coming in for Christmas. My parents are getting me, I think, biology and chemistry for Christmas. That is sarcasm. Okay, we're going to continue with this problem. So we found the integral, or at least the bounds. We found the bounds of the integral. So this area is going to equal, and I know I didn't put a equals before, but you can if you want, just to remind yourself it's area we're solving for. So we're finding the integral from 0 to 4. Those are our x points that we found by setting the functions equal to each other. The top function is, again, square root of x. I'm going to save myself a step and write x to the 1/2 power, minus the bottom function, which is 1/2 x. Close parenthesis, dx. There we go. Any questions so far? Again, it's integral from x1 to x2 of the top minus the bottom function. Great. Now I just need to solve this integral. Same thing we did before. Integral of x to the 1/2. Hopefully you know this already. It's x to the 3/2 divided by 3/2. So actually I'm going to rewrite that as times 2/3, because again, you can do that. I like to do it right away. I don't even write divided by 3/2 because I know I'm going to change it anyway. And then minus 1/2 times x to the first power will become x squared over 2. There's my integral. I can simplify it if I want, but we are going to evaluate it from positive 4 to 0. So let's plug in 4 first. 2/3 times 4 to the 3/2 power minus this 2 and this 2 I'm going to combine to make 1/4 4 squared. Did I lose anyone? I did 2 steps at once. Okay. And then all of this is minus, well, when I plug in 0, I'm just going to give you a spoiler. That's just going to turn into 0. Lucky us. So most of you will need a calculator for this part. However, I did take Algebra 2 in high school. Well, high school. So I don't need a calculator. 2/3, 4 to the 3/2 power is like the square root of 4 cubed. So that's 2 cubed, so 8. Minus 1/4 times 4 squared is 16. So we get 2/3 times 8 will become 16/3 minus 1/4 times 16 is 4. Get a common denominator of 12. You'll get 16, I'm sorry, not 12, 3. But you'll get 12 in the numerator and a 3 in the denominator. We get a final answer of 4/3. Any questions?
Where did you get the 4 from and the 0?
Yes.
In the
Yeah, let me scroll up. You're talking about this step here, right?
yeah.
So I said this 1/2 times x squared over 2 is the same thing as 1/4 x squared.
Okay.
And the minus 0 is because when you plug in 0 into everything here, like 2/3 x to the 3/2 minus 1/4 x squared, you plug in 0 there,
So
it's all 0.
Okay, it's just you plugging in your bounds, basically.
Yes.
Okay.
And I'd love to spend more time on this, but I mean, half of you probably already know what's going on. And if I slow down for the other half, I mean, we'd be here until like 10 o'clock. That's not to insult you. If anything, it's me saying pick up your game, do some more practice problems. But either way, if I'm going too fast at any point, you know, just please let me know. I'm doing this for you guys, not for my own health, obviously. Okay, I'm going to move on to the next problem. Any other questions? Okay, for the next one's kind of hard. Problem 3. I want to find the area between y equals 14 minus x squared and y equals x squared minus 4. Now, this one's not easy to draw, but I'm going to ask if there's anyone out there in the audience of the 17, the 16 of you? Yeah, the 17 of you. Do any of you know what I would draw for this function?
Wouldn't you just have 14 and 4 as the y-intercepts on like a parabola, or no?
Okay, let me do what you just said, because you're off to a good start. -4 is one y-intercept, 14 is the other. And then?
Oh, wait, and then the first function would have a downward cave?
Are you saying that because it's -x squared?
Yeah.
Okay.
And then the other one would have it like going the opposite way?
You're saying up because it's positive x squared.
Yeah.
This is correct. And again, if you didn't know this, it's not the end of the world. We can still solve this integral using the number line method, which I can do that for this one too, just to show you both ways. But we can see here we're going to have 2 intersection points. Even if you didn't know we had 2 intersection points, we could still solve this integral by setting the functions equal to each other. Oh, and the red in this case is y equals 14 minus x squared. The blue is y equals x squared minus 4. I'm sure you guys remember to bring your colored pencils to this one. I told you in the email. Yeah, that's a joke. I'm sorry. Oh well. So this integral, well, before I take the integral, if I set the functions equal to each other, I get 14 minus x squared equals x squared minus 4. How on earth do I solve this one? What I'm going to do is I'm going to add x squared to both sides, and I'm going to subtract 14 to both sides. What I end up getting on the left is 0. On the right, I'm going to have, and I'm going to simplify this in one step, 2x squared minus 18. Now, if I want to, I can actually add 18 to both sides, or I can factor out a 2. Let's factor out a 2. 0 equals 2 times quantity x squared minus 9. The 2 doesn't matter. Like, this 2 I can legitimately forget about for the rest of the problem. Why? Because, well, 2 does not have x in it. All I care about is the x squared minus 9 at this point. X squared minus 9 equals 0. This can be factored to x plus 3, and x minus 3 equals 0. Alternatively, if you wanted to, you could also say x squared equals positive 9, like I added 9 to both sides, and then you take the square root here. There's many ways to solve this problem, whatever way you feel comfortable with. Either way, you're going to get x equals positive 3 and negative 3 as our intersection points. Any questions so far? Okay, so going back to my picture, I have here is negative 3, here is positive 3. I can see which function's on top. It's going to be the 14 minus x squared. But what would I do if I had no idea? Again, make a number line. Make a number line. Here's negative 3. Here's positive 3. In this case, there's only one region we care about. It's between negative 3 and positive 3. So you need to pick a point between those two numbers. The easiest one is obviously 0 here. And you're going to plug it into both functions. Y equals 14 minus x squared and y equals x squared minus 4. We plug in 0 into both. What would we get? So you plug in 0. You get y equals 14 minus 0, so 14. For the other one, you get y equals 0 minus 4, so negative 4. Obviously, 14 is higher in this case, so the top function again, is going to be y equals 14 minus x squared. That's the first function in my integral, is 14 minus x squared. Any questions? I'm sure a lot of you have questions, and you don't necessarily know what to ask. And the other half of you are thinking right now that this kind of makes sense, but you really won't know until you do these problems on your own. Well, guess what? I have my Calculus for Dummies book with me, with the written out solutions. So what I'm going to do for you is, after this lesson's over, I'm a nice guy, and I'm going to take a picture of that entire page of problems. I'm going to send it to you guys, and if you want the solutions, you can send me an email. Just so I don't just, because I'm worried whenever I give people the solutions right away, I know you guys are just going to cheat, whether you think you will or not. I have no faith in you. I have zero trust in you. I think you're all a bunch of cheating liars who during the Zoom lectures, I'm sure all of you cheated on the exams. I have absolutely no faith that you have any integrity whatsoever. And if you do, I'm not talking about you, obviously. If you have integrity, I'm not talking about you. But for those of you who don't have integrity and you did cheat, you're cheaters. That's my big insult at the end of that. So now we have the integral from -3 to +3 of the top function is positive 14 minus x squared minus the bottom function. I need to have a quantity here. Quantity x squared minus 4. I do need to be careful there. I am going to have to distribute that negative sign to both terms. So this integral will become the following. Integral from -3 to +3 of 14 minus -4. Everyone see that? I have 14 minus a -4. That's going to be 14 plus 4, so that will become 18. And then minus x squared minus a second x squared dx. So if I simplify that, I get integral from -3 to +3 of positive 18 minus 2x squared dx. By the way, if you ever get a negative answer in any of these integrals, it means you chose the wrong function as the top function. You should always get a positive area because, well, area needs to be positive. And if you got a negative area, it means you chose the wrong thing to be the top function. So that's actually a nice way of checking. So we're going to get the following. If I take the integral of this, the integral of 18 is just 18x minus 2 times integral of x squared is x cubed over 3. Parentheses around this for notation purposes, and then long bar evaluated from 3 to -3. Once again, I need to plug in. There's going to be a lot of plugging in tonight. But 3 times 18 is 54. 54 minus 2 times 3 cubed over 3 is 9. And then minus the quantity. 18 times -3 is -54. Minus 2 times -3 cubed over 3 is actually -9. So we put this all together, you're going to get 54 minus 18 minus the quantity -54 plus 18. So it looks like this stuff almost cancels out. It kind of does. It ends up being 54 minus 18 plus 54 minus 18. It's again a symmetrical case. But you're going to get 108 minus 36. And the final answer, I'm actually terrible with subtraction. I think it's 72. 72 is our final answer. Any questions? And again, positive 72, which means I chose the right function as the top. Any questions?
So if you choose the wrong way, would it just be a -72?
Yeah, and I'm kind of realizing it just now that it's that easy. Yes.
Okay.
Of course, I mean, there's a chance that you made a math error along the way and like everything's wrong. But assuming the math is right and the only mistake you made was you flipped the top and the bottom wrong, then the answer will just be -72. Which is pretty cool. I only found this out just now. Okay, here's the next one. Y equals -x plus 3. Oh, this is number what? Number 4. Y equals -x plus 3. Y equals 0, and x equals 7. So this one's not too bad to draw. We can draw this one. We're going to have y equals -x plus 3. I'm going to draw that in red here. It looks something like this. The line y equals 0 is actually the y-axis. I can draw that in blue. It's It's literally the y-axis. I'm sorry, the x-axis. It's the x-axis. And then x equals 7, I mean, we don't know exactly where it's going to be, but it's probably going to be somewhere over here. I need to extend this a little bit longer, as you can see. But it's going to be somewhere around there. So now my region is bounded by 3 functions. It's this right here. And this time I have 3 intersection points because I have 3 functions. 1 intersection point here, 1 intersection point there, and 1 intersection point there. Now, in order to find the intersection points for this one, I'm not going to set all the functions equal to each other, especially not x equals 7, because, well, that's not y equals. You only set the y equal to each other. X equals 7, actually, that's going to be my last bound. Like, these points right here, this is x equals 7. I really just need to find this intersection point where the blue and the red meet each other. I forgot to label these points again. The red is y equals negative x plus 3. The blue is y equals 0. It's also the x-axis. And the purple is x equals 7. Any questions so far?
Yeah, I have a question.
Go for it.
So, if you couldn't draw the graph,
Yep.
Would you still be able to figure out like which one's on top, even though one of them is like x equals, or no?
Yes, because x equals 7 will never be on top. That's like the
Okay.
right or the left.
Okay,
See what I'm
so you
saying?
would still just do the same thing with the number line?
Yes. And I'll
Okay.
show you what you would do differently. Like, let's say you couldn't draw this, but they give you x equals 7 or x equals whatever. I'll show you what to do.
Okay.
But don't set them equal to each other.
Okay.
So here's what we do. We set the y's equal to each other for sure. Negative x plus 3 equals 0. This is actually the easiest case we've seen tonight. 3 equals x. Great. There's 3. Now, that x equals 7, that tells me what the bound is. If I give you x equals whatever, 7, negative 2, pi squared, that's telling me the x value, the bounds. The bounds. So right away, I know my integral is going to be the integral from 3 to 7. Again, because 3 is the first intersection point, they gave me x equals 7, which is the other bound. Any questions so far? So again, if we were to figure out which function's on top, let's say we don't know, and we make a number line, you don't put 7 on the number line. You only, actually no, technically you have to, but you put 3 and 7 here, but you're testing a point in between 3 and 7. You don't plug into x equals 7, you're only plugging into the y equals values. I repeat, 7 goes on the number line because it's an x point, but you're not plugging into the function because it's not y equals. You only plug into y equals. And again, you're going to get better at this over time. The more problems you do on your own, the better you're going to get. And that's actually one thing I wanted to mention earlier, is if you plan on coming to the Sunday review session, please tell me sooner rather than later. Space is limited. Yes, that is a marketing trick. I mean, obviously, there's no limit to an online class. But if I say space is limited, it tricks your brain into signing up sooner. And I'm pretty sure you guys are dumb enough that you'll fall for that trick. Ha ha ha. But seriously, if you want to come to that Sunday session and you're planning on saving all your studying for Sunday, I think you're an idiot. I think you're a loser. I hope you fail the test. I want you guys to study before Sunday. I'm hoping that the Sunday review is really just tying up loose ends that you still might have. Okay? I think we all know that, but sometimes I need to say it anyway, because if I don't, you guys will actually not study except for Sunday, which is bonkers to me. Okay. So again, we need to plug in a point between 3 and 7 into each function. If we plug in a number like 4 into y equals negative x plus 3, it would become negative 4 plus 3, so negative 1. And then the other function's y equals 0. I can't plug in for x. It's always going to be 0. But which number is bigger, 0 or negative 1? It's 0. So y equals 0 is on top. And again, if you didn't draw it, well, this proves it. So here we go. We have integral from 3 to 7, my x points are 3 and 7, of 0 minus quantity negative x plus 3 dx. What you're going to see is even though 0 isn't the integral, the reason that shows up in this integral essentially serves the purpose of making your final answer positive. In other words, if I, again, miss the order, I'm just going to get a negative answer. And real quick, again, I want to talk about this because look at this area. This area looks like it should be negative, right? It's below the x-axis. However, there's a reason why when we say area between curves, we want the area to always be positive. And because of that, we have to make a new definite integral to kind of force it to be positive. That's what's going on here. Any questions on what I just said? I know it's a lot of words.
Yeah, if we just put our answer as like an absolute value at the end, if we get a negative number, do you think they're gonna dock off points on the exam?
Oh, that's a good question. So I'm going to answer two parts of that, actually. So the first thing I want to say is there's a chance where they know how annoying it is to just plug in the numbers. Like I've been taking a lot of integrals today, obviously, but there's a chance they just want you to set up the integral. And if they do that, then you won't know if your final answer is positive or negative, right? Because you won't actually be solving the integral. So in a way, you do need to know which function's on top and which one's on the bottom. Now, to actually answer your question, let's say they do ask you, solve this integral. Like, tell me what the integral is, set it up, and then solve it too, and you get like a -5 instead of a +5. Seriously, if I were you, don't just be lazy. Don't just put the absolute value sign. Actually go back and say, oh, the other function was on top. Fix your work, because there's a chance, obviously, you get points docked off if you just put an absolute value sign at the end. You know what I'm saying?
Yeah, thank you.
Yep. Any other questions? So honestly, like, just for the rest of the problems tonight, just because I think you get what's going on here, I'm just going to leave this as the final integral, and you can solve this on your own if you want. But really, the most important part is, can you set up the integral? Obviously, the last quiz, we focused on actually solving the integrals, but setting up the integrals is the hard part for most of these problems. Are you guys all okay with that? If you want, I can actually solve it, but I'm pretty sure no one wants me to do that, except me, of course, because I love math. Did I ever mention I won the math award at my high school? Out of 600 students. Well, technically 598, but who's counting? Okay. Springford High School, by the way, in Montgomery County, Pennsylvania. Debatably one of the best high schools in the country for calculus. The reason I say that, I think I've told this to some of you before. I'm not sure if the whole group. But when I took calculus back in high school, it was junior year, and I remember towards the beginning of the semester, my teacher, Mrs. Artsaronian, Kelly Artsaronian, the greatest calculus teacher in probably the whole country, she told us that 80% of her students don't just pass the exam but get 5s on the AP Calculus exam. To put this in perspective, about half the students who take the exam, 50%, fail it altogether. They don't even get a 3. 80% of her students get a 5, and then on the Calc BC exam, which I also took, 90% of her students get 5s. I'm telling you, I've never heard numbers like that in any course out there. I had an amazing high school, even though it was public. It was literally a public high school. But I had an awesome math department, which is why I guess I'm doing it right now, because I genuinely love it. Okay, enough. I go on a lot of side tangents and a lot of bragging about myself, but it's for good reason. It's because I'm awesome. Now for number 5. Y equals x and y equals x cubed. 2 more problems tonight, and then you can go back to studying or whatever you do on Tuesday nights. So for this one, again, I can draw a picture. Maybe you don't know what this looks like. Maybe you do. I'm going to help you out for this one. Let's assume it's test day, and hopefully you know what the graph looks like. It looks like this. Y equals x is just a straight line that looks like this. Y equals x. Y equals x cubed is kind of a funny looking one, but it's going to look like this. Need to be careful here. I think, yeah, this is good. Y equals x cubed. You can see, once again, we're going to have 2 regions here. And again, this case will be symmetrical, so if I wanted to, I could just double it, the area. Even though one's positive and the other's negative, since I'm going to make the area positive anyway, I can just say it's double. Now, do I recommend you saying it's double? Probably not, because there's probably some kind of proof that's technically involved here, and I couldn't tell you what the proof is. I've just seen this problem enough times that I know it's symmetrical. But it's not that hard to draw the 2 integrals. I would just say make the 2 integrals. Now, the one thing that's hard about this one in particular is we have 2 functions, right? We can look at this and we can say which function's on top, which one's on the bottom, but how do we find these intersection points? There's 3 intersection points in this example. Obviously, we're going to set the functions equal to each other, but again, this is not the easiest one in the world. You get x equals x cubed. Now, one more time, a lot of you will make this mistake. Hopefully, me making it for the 3rd time tonight will make sure that you don't make it on your own, but let's say you do. Let's say you cancel out the x's, you get 0 equals x squared or 1 equals x squared, whatever you get. Don't cancel out the x's. Don't cancel out the x's. Instead, subtract x from each side, and then we're going to factor out the common term. So 0 equals x cubed minus x. Factor out the common term. It's x. So x times quantity x squared minus 1. Look at that. X squared minus 1 can also be factored. We'll get 0 equals x times x plus 1 times x minus 1 times x minus 1. We get x equals 0, positive 1, and negative 1. Those are my 3 x points, which I'm going to draw on the graph right now. Any questions so far? Great. So once again, in the scenario where I have 3 intersection points, I am going to need 2 integrals. The integral from -1 to 0, and then I'm going to give myself some space, and then I'm going to say plus the integral from 0 to 1. And now let's fill in this. So -1 to 0. Again, just looking at the graph, I can see y equals x cubed is on top and y equals x is on the bottom. But again, let's say you don't see that. Let's say you miss it. Then what am I going to do? I'm going to make a number line. I'm going to say -1, 0, and positive 1. And I don't care about the outer cases. I only care about the 2 cases in the middle, because that's the only spot I need to figure out where the function's on top and on the bottom. So we have the 2 functions, y equals x and y equals x cubed. This is not easy, but first I would plug in a number like -1/2. So y equals -1/2 and y equals -1/2 quantity cubed, which is actually -1/8. Now here's the thing. -1/2 is a bigger fraction than -1/8, which means since it's a bigger negative fraction, -1/8 is a more positive number. And in case if you're curious what I mean by that, what I'm saying is, I'm just going to scroll up. If you look at -1/2, here's -1/8 as our y point, and here's -1/2. Which number is more positive? In other words, which one's on top? It's the blue. -1/8 is more positive than -1/2. Does everyone see what I mean by that? Is it confusing? Yes. Hopefully you see it enough times before the test that you're not worried about it. In other words, for -1 to 0, y equals x cubed, that's the function that's on top. Now from 0 to 1, you're going to see it's the opposite. Y equals 1/2 and y equals positive 1/2 cubed, which is positive 1/8. Now positive 1/2 is more positive than 1/8. So y equals x is on top in the region between 0 and 1. So ultimately this comes down to this, what I'm saying. Integral from -1 to 0 is going to be the top function, which is x cubed, minus the bottom function, which is x, dx, plus the integral from 0 to 1 of the opposite. Now x is on top, minus x cubed on the bottom, dx. And again, I can solve these 2 integrals. I trust that you can do that on your own. It would take like 15 minutes probably, but I know you can do it. So I'm just going to write out the integral and let you do that on your own if you're so inclined to do so. Any questions so far? Well, I get this is it for the problem. That's all I'm going to look at. But any questions on number 5? Okay. Now we're going to look at the last problem of the night, number 6. Y equals x cubed minus x and y equals 2x. I'm going to tell you right now, y equals 2x you can probably draw. Y equals x cubed minus x. I don't even know how to draw that without looking at a graph. And if you want, you can like plug in points. You can plug in -1, 0, and +1, and whatever other points you want to check. But I'm telling you right now, for this one, this is not easy to draw. This is a perfect example of you don't need a graph to solve it. I don't need a graph to solve it. I'm going to do the method where I plug in. I'm going to set the functions equal to each other. I'm going to see which one's on top and which one's on the bottom by plugging in numbers into the number line, and that's what I'm going to do. Y equals x cubed minus x, y equals 2x. So again, we cannot set these 2 functions equal to each other. I mean, that's what we're going to do. We cannot draw a graph. So I'm going to say x cubed minus x equals 2x. Hopefully you know by now what we're going to do. I'm going to subtract 2x from both sides. I get x cubed minus 3x equals 0. And then I need to factor out the common term, which is x. So x squared minus 3 equals 0. This is not a fun problem. Oh well. So x squared minus 3 does not solve very nicely, but we get x equals 0 for the one solution. The other one, x squared minus 3 equals 0. To solve for that, what I need to do is add 3 to both sides, so we get x squared equals positive 3, and then I need to take the square root. But whenever I take the square root, don't forget it's plus or minus, right? So x is going to equal positive square root of 3 and negative square root of 3. So there's my 3 intersection points. Even though I can't draw it, I'm still kind of going in blind here. If I make a number line, I have negative square root of 3, 0, and positive square root of 3. These are my 3 points. Which, if you didn't know, square root of 3 is equal to about 1.7, which means I can plug in negative 1 and positive 1 here for my points in the middle. It's actually not too bad. So again, the functions are y equals x cubed minus x and y equals 2x. First, let's plug in, wait, was that right? Yeah. First, let's plug in negative 1. So y equals negative 1 cubed minus negative 1. That's going to be negative 1 plus 1, we get 0. For y equals negative 1 into 2x, we get y equals 2 times negative 1, you get negative 2. Which function's more positive? It's x cubed minus x. X cubed minus x is on top for the region between negative 3 and 0. Again, this has 3 intersection points, which means I'm going to have 2 integrals, 2 areas to add together. And then for my other point, I'm going to plug in positive 1. So y equals positive 1 cubed minus 1, that's 0. And then the other one's y equals 2 times positive 1, which is 2. Y equals 2x will be on top between 0 and root 3. So if I were to set up my integral, and again, I'm not going to solve it, I'm just going to set it up. It's going to be the integral from negative square root of 3 to 0 of the first top function is x cubed minus x, and then minus 2x. And then and then dx. And then the second integral, it's going to be the opposite. The integral from 0 to square root of 3 of the top function 2x minus quantity x cubed minus x, close parenthesis, dx. I'm going to circle this. This is my final answer. You can stick around for questions if you want.